Hey, amazing people. What we're going to do is we're going to look at some examples here where we're looking at these annuities, but we're looking at them as a geometric series. Now, whenever we're doing this, one of the key things is that we need to work out 3 in a row to establish the pattern here before we can start to jump ahead. If you've only got 2, you haven't established a pattern yet. If you've got 3, then you can establish that pattern and be confident in it. That's why we always need 3 here. So what we're going to do for this question here, we're going to do those first 3 and then jump to the last because we've established a pattern, and then from there start to work out what's happening. Now, in this question, we're told a man invests $750 at the beginning of each year in a superannuation fund. If the interest is paid at a rate of 8% per annum on the investment, compounded annually, how much will his investment be worth after 20 years? So first things first here, in interpreting the question, we're told that it's at the beginning of each year this contribution is made. And this is really important thing to pay attention to in these questions. So therefore, the first $750, it's going to be invested for 20 years. That means the second $750 is invested for 19 years. And we've also got the third $750. It's invested for 18 years. Now, we need to work out an equation for each of these. And what we're going to do is we're going to use compound interest for this. So using the compound interest formula, for the first year, it's going to be 750 times, the rate is 8%, so this will be 1.08 to the power of 20. Now, for the second year, it's going to look similar, but it's going to be 1.08 for 19 years. Then we're going to have 750 times 1.08 for 18 years for the third year here. Now, we're just trying to establish a pattern at this stage. And so if we get to the last year that it's invested, the $750 is invested for 1 year. Okay, now what we then need to do, we can draw a line underneath this. We need to work out what the total investment is we have. So we want the total investment amount. And that's after the 20 years. Now, as we go about this, we need to take this information and put it all together. So what we've got is we've got 750 times 1.08 to the power of 20, plus the second year we added another 750. That's times 1.08 for 19 years, plus 750 times 1.08 for 18 years, plus continues on until we get to the last year. We've got 750 times 1.08 to the power of 1. Now, this is where we're establishing our pattern here. And so what we're going to do from here is we want to start to factorize this to help us understand it. So from here, okay, let's rearrange this. Now we can see we've got, in each case, 750 in each of these. So one of the first things I'm going to do is I'm going to factorize that 750 out just to make it a bit easier for things here. Now, in addition to that, what I'd like to do is I want to swap the order around of the 1.08. I want to put the smaller one at the beginning and the larger one with the higher power at the end. So what I'm going to do is I'm going to put 1.08 to the power of 1. And because I factorize it, it's just plus. Then I'm going to have 1.08 to the power of 2. Plus 1.08 to the power of 3. And I've got my 3 in a row here, so I've established my pattern. So then I can jump ahead to the last one, which is going to be 1.08 to the power of 20. Now, from this stage here, this helps us a lot better because we can see that we've got a geometric series here. And so let's pull out a few key points of information. Now, we're only focusing on the bracketed part here. Now, we know our first term is going to be 1.08. The rate, because it's timesing by that each time, is also going to be 1.08. And then lastly, we can have our n value as well, which is going to be 20. Now, when you have values like this is a geometric series. We can find the sum of it. So the sum of n is equal to a r to the power of n minus 1 all over r minus 1. And this is what we have here. And so this key thing, this key formula is what we're about to use. So as we do that now, we're going to have s to 20. That's going to be equal to 1.08 being the first term, times, open bracket, 1.08 to the power of 20, minus 1, close bracket, all over 1.08 minus 1. And so that's just telling us the worth of the bracketed component. So now if we work out the whole thing, we've got that 750 outside of that we also need to bring into it. So the investment value now, what that's going to be equal to the 750 times, in brackets, 1.08, brackets 1.08 to the power of 20 minus 1, all over 1.08 minus 1. Now, when we type this into the calculator, we get the investment value at the end. And what we end up with is $37,067. This is rounded to the nearest dollar here because we're dealing with quite large amounts. But this is going to be the total investment amount into that superannuation fund at the end of those 20 years.